Alright, this is a video where we're talking about how fats are processed by cellular respiration for the production of ATP. The first thing you got to notice is that a fat molecule is made up of glycerol and 3 fatty acids. Alright, now a couple of processes will actually enable the fat to be broken down and used in cellular respiration for the production of ATP, and we'll go through those. First thing we've got to look at is the fatty acids themselves. Fatty acids are chopped up, and they're chopped up in 2 carbon sections. And every one of those cuts uses energy and produces energy. So if you look at this fatty acid right here, every 2 carbons we've got a red cut. Every 2 carbons, a red cut. And you'll notice that now we've got 5 cuts. Now every cut will make 1 NADH, 1 FADH2, and use 1 ATP, which is why we have a -1 here. All right. Now they end up going, the NADHs and FADH2s end up going through a cellular respiration, the electron transport chain, chemiosmosis, and NADH makes 3 ATP, 1 FADH2 makes 2 ATP. Now, if every fatty acid in this particular molecule makes 5 cuts, then and we have 3 fatty acids, that gives a total of 15 cuts. So all these numbers get multiplied by 15. So -1 becomes -15, 3 becomes 45, 2 becomes 30. Add that together, you get 74 ATP. Now the 2 carbon molecules that are made from these cuts produce acetyl coenzyme A. And as you know, acetyl coenzyme A goes through the Krebs cycle. And the Krebs cycle makes, for every turn, 1 ATP, 3 NADHs, 1 FADH2. And we know that these NADHs will make 3 ATP per NADH. 3 ATP per NADH, that's passing through the electron transport chain. So 3 times 3 gives you 9. And we also know that every FADH2 processed by the electron transport chain makes 2 ATP. So this is where the 2 ATP comes from. So that's 9, 10, 11, 12. All right, and we have 18 of them, 18 acetyl coenzyme A's, because we got a piece there, piece there, piece there, here, here, and here. So there are 6 per fatty acid. 6 times 3 gives us 18 acetyl coenzyme A's. So 18 times 12 gives us 216 ATP. The last thing that happens is the glycerol portion of the fat goes through a process called gluconeogenesis, and it actually gets converted to G3P in glycolysis, and then will pass through the remaining steps of glycolysis, go through pyruvate oxidation, as well as the Krebs cycle. And when you look at the number of ATP, NADHs, and FADH2s that you get from those 3 stages, it ends up being 3, 5, and 1. So these 3 ATP will just carry over here. 5 NADHs produce 14. 4 of those NADHs come from pyruvate oxidation and from the Krebs cycle. The other NADH comes from glycolysis, and that one that comes from glycolysis only produces 2 ATP instead of 3. So this is why this ends up being 14 ATP instead of 15. And this one, FADH2, again, will only produce 2 ATP. Add that together, you get 19. So when you add that total together, 74 plus 216 plus 19 gives us a total of 309 ATP from this particular fat here.